Oh yes.
No, so you said that the coil, the thermocol should be kind of squeezed in by the
Yeah.
coil.
Yeah. I'll
I
tell
was
you
able
that.
to understand that.
I'll tell you that. I'll tell you that. Two things I missed out. Yeah. One is, guys, I'm recording
Yes.
this for, again, this thing I'm not able to make. That's your thermocol piece from the side.
So you're not sharing your screen.
Oh wow. Thanks. This is your thermocol piece from the side. Okay. Got it?
So, sir, we should cut
This
it
is
off like
your
this, is it?
this is your pencil hole where the pencil is going through. Are you getting the point?
Yes. Yes, sir.
This is where the wires will be coming. Okay. So if
Yes, sir.
depression over here, what is going to happen? A lot of wire can be inside here, right? And then depending on the thickness or gauge of the wire, I have told you to take the thin ones. Okay. You
Yes, sir.
can with different gauge, it may come out like this also. So much it can protrude also. Okay. I had a question in the starting to ask, if it is like too near, what happens? I'll tell you what happens. If it is too near, my magnetic strength is great. This is the pencil. I know my magnetic strength is great because it is too near. The wire is here and here. But then forces on the wire is not going to give a good torque. Bigger is the force arm, farther
Okay, sir.
force is better is the torque. Like if you want to open the door, you do open it from the far end of the hinge, not near the hinge.
Yes, sir.
At the far end, it is easier to pull and push. At the hinge, it will be very difficult to pull and push to open. But if I was making it far, then my magnetic strength was getting reduced, right? So there's a
Yes, sir. So it has to
how
be
near it should
perfect.
go or how far it should go. So the dimensions I've given you is like genuinely good dimension for my magnets. Okay, so it all depends like what you are using and all. Okay, you can go even closer if you want. Okay.
So, sir,
So in
basically
the
the
third,
reason.
The power supply. So for the
No.
power
One
supply,
second,
we
one
can
second, one
just.
second. Let me complete. Let me complete. Then this thermocol and the pencil, you rather put some glue over here. I'll put in blue. You put some glue over here so that it is actually sticking, right? Now the coiling, what you were doing, as often as you can take it round like this, across this, and then bring it from here, take it from here, sometimes bring it from here and take it from there, sometimes bring it from here and take it from there. Is that clear?
Yes, sir.
So more it happens where it is balanced from all sides, this. What is going to happen is you'll have a properly balanced coiling. Okay, and this will be tightly fitting on this, which I was checking. If she has done it properly, don't have to put so much of glue and all. Okay, the coil itself will be quite tightly fit. Is that clear? Do
Yes, sir.
cut and join the pieces of the wire. It has to be a single one. Okay, long single one. Get the point? If you cut and join, you have to scrape off the enamel, join properly, then put some coating on it, say wax on it and all, and wrap it around and check the connection also whether you have your that thing is right or wrong. Don't do that much, okay? And let it be neat. Things wire should not be flying out here and there because they are all going to hit. So whatever extra after this cylinder over here, whatever extra is there, extra wire, okay, either you can
Yes.
in, she has tucked in very beautifully, or you can clip it off. If you know that yes, your job is done properly, you can clip it off, okay, or tuck in somewhere. Okay. Obviously this end
Yes, sir.
never touching that end of the wire. Yeah, any
So,
other?
sir,
so
so,
that
sir, we will
cylinder.
cut the thermocol piece in that shape, right? Like with those two
Yeah, you
hollows
take a
on the sides. Okay, sir.
normal thermocol. You take
Yes,
the
sir.
dimensions I told you. Okay.
Hmm.
Then what I do is, at my place, if I have a hot rod, okay,
Yes, sir.
I just bring it near. Don't even touch it, okay? Bring it near, this much near, the hot rod, okay? With the heat, it sinks, okay?
Okay, sir.
That depression. Because that time, no, I'm just sitting with the soldering iron for others to come and get this joint, get that joint. So when they come, I just put it nearby. So sometimes to put the hole over here, I'm sitting with the thermocol, all that with the soldering rod. So I just put
Okay, sir.
it here and it sinks. You may do it in your own way. Okay, not a big deal. Okay.
Okay, sir.
I'll tell
Sir,
you
Sir,
what I tell you what one child has done. What one child has done. She had a normal thermocol piece, no depressions and all. Okay. In fact, this is what I had told that year people to do. Good cardboard. Put a good cardboard on top. ठीक है ऊपर में कार्डबोर्ड डाल दिया कलर आई चेंज
Yes, sir.
सी and stick it properly with Fevicol and put a cardboard over here. Then this is less than the width I told you. Okay, slightly
Yeah.
less.
Oh,
So automatically it is having the depression, right?
yes, sir. Okay, sir.
So any ways you can do it. Okay, don't follow that. Okay, Nimish sir said that you do it like this with the rod. No, you saw the point, right? What has to be achieved? I told you about the distances. I told you about the magnetic strength. I told you about the length.
Yes, sir.
What is ideal and all. Then you achieve it in your own way. Get the point?
Okay, sir.
Putting a pencil which tightly goes through and later this should not rotate is a catch. Okay, is a problem every year for everybody. So you do that part properly, and this should be in the center. Once you have achieved the center, then you start coiling. पहले coil कर दिया, which is not possible at all, by the way. But this is not at the center. No, there it's a big problem. Are you getting the point?
Yes, sir.
If you put the thing over here, ये तो बिल्कुल भी काम नहीं करेगा. Okay. Okay. Centering is a big issue which you have to take it properly, do it properly. Okay.
Sir, like,
sir,
Yeah. Ask Sriniket.
sir, like this doubt which I had, is it fine if it's like slightly off center again? Because we are doing by hand, we are not getting some plastic stopper. So that's why I wanted to know.
I think you have made something and you are worried about it.
No, sir, seriously, sir, I'm not me, but I'm
Like
asking.
how
because,
off center? You just send a photo.
like 1 centimeter. No, I'm not done yet. But I'm like
1
2
centimeter off center. What are you saying, man? 1 centimeter off center. What are you saying? How big are you making?
No, sir, I didn't make the mistake. I'm just asking.
Yeah, if this is a 10-20 centimeter thing, like a big motor, bigger than your face and all.
Oh, 10-20 centimeters, like 1 mm, 1 or 2 mm, like that.
Wow. Little bit here and there, I think it is okay.
Then fine.
If this thing is not centered, no, this one part. If this is not centered, then what is going to happen is, let me just show you over here. This is not centered, okay, slightly not centered. So how far is the carbon brush over here? This far is the carbon brush, right? Get the point? Now, when this part comes on that side, it is not going to touch the carbon brush. It might not touch, okay? Is one issue, connection issue. Secondly, this whole thing will be shaking and wobbling a lot, okay? It is going to go wobble, okay? I hope you understand, right?
Yes, sir.
Yeah, in the phone. When I'm wobbling, it is not coming properly. Like this, it is going to wobble. Got the point? Anyways, yeah. Next.
Excuse me, sir.
Yeah.
So any particular reason why you suggested to use a doorknob?
Yeah, it has got a center. It has got a good diameter, which is the ideal diameter. And it is easily available in all the shops nearby.
Excuse me, sir.
Sir, I also have a doubt, but it's not related to
they are selling two kinds. One good quality heavy doorknob, one very light one. Take the light one. We want the light one, the cheap one. Okay.
Yes, sir.
Excuse me,
Sir,
sir.
And
sir, I have a
also-
doubt, but it's not related to construction. It's more related to like the electricity, how it gets generated. I have a doubt.
Somebody said that they have some pipe or the aluminum cardboard or something. Okay, that's also good. You fill it up fully. and with rigid thing, then you make a hole in it. Okay. If you can't fill it up, then what you do is put a cardboard on this side, stick the cardboard on this, put a cardboard on that side, stick the cardboard on that. Get the point? Get the center right, which will be a pain. Cut this cardboard off, get the center right, and make a hole through it. Okay. This is not recommended, but okay. Filling up is more recommended. Okay. Next.
Excuse me,
Uh,
sir.
Sir,
Sir.
Hmm.
Sir, the width for the thermocol that you gave in the starting of the class, is that with the depression or without the depression?
That is without the depression. There would be, say, add the max half a centimeter depression in it. Okay.
Okay, sir.
On both sides.
Sir.
Okay. Half here, half there.
Sir, like I have a doubt, but it's not related to construction. So can I ask like separately?
Yeah. Yeah, separately. Put it in the doubt group, no, Shriniket?
Yes, sir.
So, when you were explaining before with about the aluminum foils that you put in the side, you said that we might encounter a problem and make sure that we align it with the top or something like that. I didn't understand what you were saying then.
When this is flat like this, the slit should not be here. The slit should be here. When this is flat, in flat position, the slit, are you getting it? Are you listening?
Yes, sir.
The slit should be here. Okay. When that is in the vertical position, when this coil is in the vertical position, that time the slit should be like this. Add the carbon brushes. Okay.
Okay, sir.
We have discussed the reason, right? Because when it is vertical position, that is the time we want to change over. CD side going on to the positive and AB side going on to the negative, right?
Yes, sir.
At the vertical position, the slit should be like that. Okay. Yeah. Anybody else? हेलो हाँ सर अभी मैं क्लास में हूँ मैं आपको कॉल करता हूँ बाद में हाँ जी नाउ गाइस
So like when we were discussing the motor, and that time Sriniket had said, what if we have the magnets rotating along with the motor? So won't that be like more?
what happens is that is also there okay what happens is the outside is actually coils okay of poles and if it is a three-phase motor which I cannot explain you in too much of detail this is phase 1 phase 2 phase 3 phase 1 phase 2 phase 3 overlapping also by the way it is not like 2 3 and then 1 2 may overlap and all when this is peaking this is not peaking their AC diagram is something like this. So when this peaks, this is lower, then that peaks, then that peaks. So it is like it is a stimulated, which I told him, a virtual rotating magnet, which is true, which is you understand that when this was plus, it becomes minus, and North Pole is going to become a South Pole. That much you understand, right? That's the absolute difference, right? Plus to minus, North is going to become South, South is going to become North. This is North. It seems when this peaks, it seems like North has come over here. Then seems like North has come over here. So it seems like that North is rotating round and round. Get the point? Because the current is such a beautiful pattern. Get the point? So then I was telling you about a synchronous motor locking and stopped short and did not say further on that. This is your in-between wala coil, which is like a North and South Pole. It is in fact a North and South Pole. North gets locked with a, say, south over there, and the south rotates like this, then the north rotates like this. This is an absolute synchronous motor. Here's the point. We have all various kinds of motors with various vibration. Okay. What we generally have a squirrel cage induction motor. And if I have someday, I'll explain you what is a squirrel cage induction motor, but not required at your phase. Understand the basic phenomena, how the motor and generator is working, that is enough. And bit of construction so that you know the practical ends. Like if you know theory, there is a lot to actually make something a real world application. Therefore, I'm doing this so that you appreciate the people who make stuff, not only the people who imagine stuff. So imagining that and putting a theory is one big thing, and then actually making up something with that is another big thing. Okay. So this is your imaginary rotating magnet, what Sriniket was talking about. We don't have an actual practical magnet on another motor rotating. Then there is no purpose. It's not energy saving and all. Okay. Then we have motor on motor, piggy banked on motor to synchronize it. Okay, that is an induction motor, synchronous motor, piggy banked on an induction motor. All those things setups are there. So when a certain industry requirement is there, then you will work, you will think about it. Okay, that I do this, and then that requirement is fulfilled. Like somebody wanted to make a printer, and then he said, okay, motors are required, but I want this kind of exact thing, and he'll work like that. He'll think of making a motor like that. So once a requirement is put, you put your theories together and see whether you can construct a thing which can solve the purpose or not. Okay, yeah, next. Guys, ask with respect to what I have been teaching you. Yeah, next. Anybody?
Okay, sir, can I ask my doubt? It's not related to construction, but
No. Actually, I have to rush to hospital now. Okay, if it was not any short of that, on this anybody can ask. I would have taken your doubt. Okay. There is something which is quite urgent. If it becomes late, then they won't be there at the hospital. Okay. Okay. It's not an emergency, but it is something which has to be done. Anybody with respect to today's class? Sriniket, you put your doubt. Late night, I'll come back and I'll answer your doubt on the group.
sir, I've already put it on the group.
Okay, cool, man. That's good. Okay. So that's it, guys. That's it, guys.
Yes, sir. If you have any more doubts, I think we can type it in
Yeah.
the chat.
Yeah. Please do that. Okay. Chalo, bye. Sriniket, you have put.
Thank you, sir.
Bye,
Yes, sir, I
sir.
put-
Thank you, sir.
Sir, you
Thank
said
you so
when
much.
the
Okay, sir. Bye,
construction you
sir.
create without the battery is the construction of a generator, and all we have to do is rotate it. Now, if rotating the magnets, will it still produce? Yes, it will produce current. Okay.
So I just thought that because in the end, it like for the object, for
Yeah,
example,
it
if I'm
produces current.
moving, yeah,
It produces
That's
current.
what I
But
thought.
if you want to rotate the magnet, you require another motor where you have to be putting the current, which is a worthless job. So you have to rotate it mechanically by idly or something. Okay.
sir, what if we just move the thing in and out or something?
Yeah,
Move the
for moving.
No,
What do you
yeah,
do for
mechanically only.
moving?
We are pushing.
Yeah, so you are not there as a human. Will not be pushing it all the time. No. What do you want to do?
So what I just want to do is, for example, sir, like how like a normal hydro.
Yeah, so Heidel,
thing
yeah,
works,
so the
sir.
Heidel thing. So Heidel, okay, Heidel. So you can
Yes, sir.
put it on a Heidel thing which is rotating. So it is not a better construction than keeping that stationary and moving the inside thing itself. Okay. So what is
And sir, also what I thought is, would it also work if the magnet is moving, not rotating, just moving up and down?
Yeah, sir. That is like a very poor field it will give. It will work. Whenever there is a change in field in front of a conductor, whether conductor is moving or magnet is moving, current is going to be produced. Okay.
So sir, it's basically like
Kind of
similar to
current
like
we
how
want. We want a pure sinusoidal or not. If you want a pure sinusoidal, we rotate it round and round. Okay. So that the whole of the world is having the same benchmark of the current, and you don't have a TV made for your current and somebody has made a tube light for his current. So we have to have a same kind of current, right, for everybody. So there are
Yes, sir.
requirements. Okay. Theoretically, yes, it will.
So the reason why I thought is basically like when I'm moving front and back, I'm basically like creating like almost like an acceleration almost or sort of. And then I related that to
Shriniket, I'll ask you a question on this. Okay. Everybody, if people are over here, otherwise recording will go. Answer this. Shriniket, answer this next time. I think I would be happy about it. Suppose I hang a North Pole, South Pole thing. Okay. And I put a coil over here. I put a coil over here. This is light bulb. If I move this magnet, is the light going to glow? Yes. Okay, I'm not even asking that. Yes, it is going to glow. Okay. Now, if the coil is not there, I'm telling you, if I move it like this and let it goes on till infinite time. I put a very smooth bearing and all, and it is a good pendulum. At least for 10, 20 days, it is going to work. So if I just move it like this, north, south, and let it go with a coil in front, is it going to give me light for those 20 days or not is my question. Next class you answer. Okay. Like I've created a good supply of energy in my house without doing much. Okay. Okay. Chalo. Anything else?
okay, sir.
You answer
No,
this,
sir.
Srinike, then I'll answer your part. Okay.
Okay, sir.
Okay.
Thank you, sir.
Thank you, boys.
Thank you, sir.
So we
Bye,
can
sir.
calculate